And all to another lesson on graphing linear equations. So that's again chapter 12, lesson 7. I may or may not put all of these onto the computer. So if I did, go ahead and check Google Classroom. And I would invite you to first complete day 3. I might also put day 5, I'm not sure. And then come on back and check your answers. So day 3, here we go with the answers. Pause. Come on back when you're ready. And of course, if you have any questions, let me know. Send me an email, message me, or catch me live on the Google Meet. All right, next up, I'm going to go to day 5. Again, I'm not sure yet if I'm going to put that on, but if I do, pause, finish day 5, come on back, and check your answers. And to the second page. And homework answers from previous, sorry, that's not assignment number 20. I think that's assignment number 7. But check out page 349, 9 to 20. I gave you some graph paper. Pause and come on back for the next 4 when you are ready. 4 more coming up. Or I guess I should say 3 more. All right, folks, objective for the day. You should walk out of this lesson saying, I know how to graph linear equations. Now, we're going to use what we've previously learned about t-charts. Of course, in order to make those, we have to be able to compute positive and negative rational numbers. That's integers, that's fractions, that's decimals. And sooner or later, we're going to graph not just 1, but 2 equations on the same graph. And we're going to say, okay, here are all the solutions to one of those equations. And here are all the solutions to another one of those equations. But is there a solution that is shared by both? You might know where we're heading. There will be an x value and a y value that if you substitute it in to both equations, it's going to be true for both. But we'll get there sooner or later. For today, let's just focus on graphing a single linear equation. Now I'm going to start off, I'm going to ask you to pause and come up with your own t-chart and think about what the lines will look like for y equals 4 and x equals -2, and pause, come on back when you're ready. Now, if you recall, it's been a while, but I always started with 0 and then I chose 1 positive and 1 negative. Okay, so I want you to think about if x equals 0, what must y equal? Wait a second. There's not even an x term here. You could say there are 0 x's and then a positive 4. So yeah, I suppose you could substitute in 0, but it doesn't really change anything. I mean, 0 times 0 is still 0, and y equals 4. All right, what if the x value, the input value, was different? What if we had 1? Again, 0 times 1 is still going to be 0, and y equals 4. All right, what if the x value is -1? You might understand by now. I used to use green, but I'm not sure it matters for you guys. So with that in mind, I can now go ahead and substitute or plot these ordered pairs, -1 to the left, +4 up, 0 to the left goes neither left nor right, +4 up, +1 to the right, +4 up. I mean, we could use all sorts of x values, but it still has an equation that says y equals 4. And so you might imagine that we're going to have trillions and trillions and trillions, and therefore when we draw our line, it's going to be a vertical line everywhere where y equals 4. Now, keep that in mind down below. We can't put 0 in for x because it says x must be -2. Now, y could be anything. Y could be 0. But if I have another x of -2, maybe y is 9. And if I have another x is -2, maybe y is -4. 4 2/3. Now imagine what this graph looks like. -2 to the left, 0 goes neither up nor down. Got it. -2 to the left, +9 goes way up. Got it. -2 to the left, -4.5. Got it. And you can imagine we can continue putting -2 values in, and while the y value might change, the x value does not. And so picture if the x value must always be -2, we have billions and trillions of different possible solutions when x is -2. Y could be anything, but x must stay -2. So here's what an equation looks like for x equals -2 graphed on the coordinate plane. Now usually, folks, we'd have something different, right? We'd actually have to multiply the input by some coefficient, and maybe or maybe not have some addition or subtraction to do at the end. But I wanted to show you these two examples when there is no x in the equation, when there is no y in the equation, so you can get a brief glimpse of what those will look like. Now, this is where we are heading, so I'm going to go ahead and zoom in on the directions. It says circle 3 linear equations in each box and write them over the t-tables below. Then we're going to go ahead and we're going to complete each table with at least 3 ordered pairs, but you have to make sure those ordered pairs are something that's going to fit on the graph. Oops, I shouldn't have done that. Let me see if I can redo that. There we go. Because when we go to the next page, you'll want that to fit on this graph, and the largest numbers you can get to are +10 and -10. So you got to be careful and choose wisely. Anywho, so I just want to point out that it might be wise, take a look at the first box. Maybe in this case, whoops, if you're going to circle 3 equations, maybe you should circle, there's a negative and there's a positive and there's a positive, okay? So don't just choose all the negatives, don't choose all the positives. Same thing in the next box. Maybe you choose 2 negatives and a positive. And the next box, now look at all these coefficients. So maybe what I'll want to do is I'll want to choose one that's a fraction, one that's a whole number, and maybe one that's not even got a number in front of the x, although just because you don't see it doesn't mean it's not there, right? It's really a coefficient of 1. And I'll do the same thing for the next one. Maybe I circle that first one, and then I circle this fella, and then I circle, ooh, this guy's interesting. It doesn't even have a number. Well, just because you don't see +0 doesn't mean it's not there. So what you would do then is you would take one of these, you would write all those equations, like I could write y equals -2x, I could write y equals 1/2 x minus 3, y equals -2. I mean, I'm going to go ahead and write all those equations. And then I'm just going to follow all what we've learned the last few days. So you might have to go back and rewatch a video. I'm hoping not. But if you notice, there's a reason why I did what I just did with the previous assignment. You can see from this box, it says all x equals. You can see from the next box, it says all y equals with nothing else over here. So maybe you might have to rewind the video and go back. Now the point is, at that idea, we got x equals 2, y equals -2. So sooner or later, you're going to plot your points, whatever your 3 points are, and then you're going to draw lines through them. And I should have drawn those lines all the way, and I mean all the way through the graph, the arrows at the end. Maybe I chose y equals -2, so my line looks like this. And then y equals, what else did I choose? 1/2 x minus 3. Maybe I get points that look like that. And sooner or later, what you're going to do, this is called stained glass exercise, stained glass window, because you're going to make it look like this. Boom. Go ahead and very neatly write the equation right next to every line, and then start coloring in the little part, make your own stained glass. Now, everybody's answers are going to look a little different because everyone is going to choose different equations. At least that's the way I'm setting up the activity. I could have made the whole class choose the same equations as me, but I'm not going to, right? So why don't you go ahead and complete that exercise. Again, your goal, choose 3 equations from every box, complete T-charts for all those equations, so you should have a total of 12. And then graphing all those points and drawing the lines all the way through and then coloring them in to make it look like this. That's what I got, folks. Take care, do well, and let's grow.